The title of our project for NUMELAB is the relationship of collector current to beta of transistor using nonlinear regression. So the beta of hFE of the transistor is the current gain or the amplification factor of the transistor. A transistor works by feeding a current into the base of the transistor. The base current is then amplified by hFE to yield its amplified current. The formula is IC is equal to hFEIB is equal to beta IB. Every transistor has its own unique hFE. The hFE is normally seen to be a constant value, normally around 10 to 500, but it may change slightly with the temperature and with changes in the collector-to-emitter voltage. Using the polynomial regression, we would be able to see the nonlinear regression relationship of collector current and beta of the transistor. So the first thing we did is construct a circuit, after which the base from the data sheet, the value of our VCE for this project for all the tests should be 1 volt. From there, we can vary the value of our collector current, IC, by adjusting the potentiometer across the base of the transistor. After getting the IC, we will then measure the base current, IB, in order for us to know the beta. Since the formula for beta is equal to IC over IB. We will then input the data in our Excel, then using our program in Python, we will be able to get the nonlinear curve relationship of collector current and the beta of transistor by applying the polynomial regression. For our code, for the Python, we import numpy as np, import matplotlib.pyplot as plt, import pandas as pd. So for the dataset is equal to pd.read_csv project data.csv, where x is equal to datasheet.iloc, y is equal to datasheet.iloc. So linear 1 is equal to linear regression, linear 1.fit x and y. So polynomial regression from sklearn.preprocessing import polynomial features, poly_reg is equal to polynomial feature times degree is equal to 2, x poly is equal to poly_reg.fit_transform x. Linear regression is equal to linear regression, linear reg.fit x poly/y. PLT the plot x linear reg that predict x poly, PLT that x label, and PLT y label for beta. So we can see that in our code that we use the polynomial linear regression for our code, and that the data are acquired for our plot is from the project data.csv, because we need to input our x and y values for our Excel, and then it will automatically set the graph for our x and y values, which are the beta and the IC. So we start, or based from the datasheet, the IC we used in milliamps is 1, 10, 50, and 100. Each of our transistors are tested individually 5 times, so we can see if there is a sudden change in the beta. And as we can see that there is a big difference in changing the transistors one at a time, and some remain the same. We also observed that 1 to 10 milliamps, the beta increases as the collector current increases. However, it began declining when the collector current is increased from 25 milliamperes to 100 milliamperes. Based on this, in order to get the maximum gain, we should not increase the collector current too much, since the beta decreases at certain point even though the collector current is increased.